So frustratingly, once again, my audio did not record on there, so I'm going to re-record this one more time. Today, I'm just going to do one problem. It's going to be a word problem about our two variable inequalities, and then I'm going to look over how to check a solution. So let's dive right into example 3 here. I'm ready to go. Tina sells posters for $10 and framed photos for $15. She wants to make at least $60. Write and graph an inequality to model how many posters and framed photos she can sell. So we want to set this up. Again, it's a two variable inequality. So I want to figure out what my variables represent. There are only two things I see here that are variable factors here, posters and photos. So I'll say, let's let the posters be X and the photos be Y. And in that case, we can say she's getting $10 for every X poster she sells, 10X. And then she's adding to that $15 for every Y framed photos she sells. And we want her profit, that expression total, that value, to be at least 60. Remember, at least means greater than or equal to. So our inequality we can write is 10x plus 15y is greater than or equal to 60. And then we can solve that or do something else in order to graph it. I'm not great at graphing straight out of standard form, so we have a couple options. We could solve for y and go for slope-intercept form, or remember real world context. A lot of the time, if we're given a standard form equation or inequality, we can solve graphing using the intercepts. So let's think intercepts. What happens if she's only selling posters? What if she can't sell any of her photos whatsoever? If we don't have any photos there, we have 10x is greater than or equal to 60. That would represent how much she's making and how many posters she needs to sell to get that $60 profit. So 10x is greater than or equal to 60. We solve that by dividing 10 from both sides. We get x is greater than or equal to 6. So she would have to sell at least 6 posters. And again, that's if she's not selling any framed photos whatsoever. And then let's look at the flip side of that. What if she's not selling any posters? Let's find the y-intercept for if she's only selling framed photos. 15y is greater than or equal to 60. Divide that 15 over from both sides, and we get y is greater than or equal to 4. So without selling any posters, she would have to sell at least 4 framed photos. And we can use these intercepts to graph our inequality. I actually really only care about, in this real world context, the first quadrant, because I'm not going to be selling any any negative amount of photos or posters. So go ahead and put my intercepts down. We've got an x-intercept of 6 posters. We've got a y-intercept of 4 framed photos. So those represent our intercepts there. And here's where, again, don't want to use anything outside of the first quadrant. I'm not going to sell negative posters. I'm not going to sell negative photos. So I really only care about this first quadrant up here where everything is non-negative, either positive or 0. And then I'm really just using a line segment. I'm not using the full line because that stretches into the second and fourth quadrants. I'm just going to do that segment in the first quadrant connecting the two intercepts. And then we are greater than or equal to 60. So we want our profit to be bigger than this or equal to this. So I'm shading above. If I sell more posters or sell more framed photos, that's going to be part of the solution. So I shaded everything above it right there. In some of these, you can kind of see this represents all the possible ways she could make $60 in reality. So some of them are pretty easy. What if she sold 7 posters and 4 photos? Well, the 0.7, 4 is there very easily. 7 posters here and 4 photos right here. It's very easily seen that that's part of the solution. It's in the shaded region. But what if I said 4 posters and 1 photo? See where 4, 1 is? That's really close to that line. Is it on the line? Is it in the shaded region? Is it not? So we're going to check 4 posters, 1 framed photo. That's the ordered pair 4, 1. Because remember, my posters were my X variable and my framed photos were my Y variable. So the point 4, 1, is that a solution to this inequality? So let's substitute 4 in for X and 1 in for Y and see if this is true. $10 per poster. We sold 4 posters in this scenario, plus $15 for the one photo. Is that greater than or equal to 60? So we want to know, is it greater than or equal to 60? Let's find out. 10 times 4 is 40. So she's making $40 from the posters, and we know she's making $15 for the one frame photo. Is that greater than or equal to 60? Well, that comes up to be 55 is greater than or equal to 60. Is that right? Does that work? No. If we wanted a profit of at least $60, 4 posters and one frame photo is not enough. The 0.4 comma 1 is not a solution here, because when we substitute it in, it ends up with an invalid inequality.